Hi guys, this is Miss Wesley, and we are starting Unit 6. And Unit 6 is probably my favorite unit. It's our trigonometry unit. So we're going to start here with Skill 1, and the essential question for today is what are the 3 trig ratios we use in geometry, and what is the process? So meaning, how do we use those 3 trig ratios? And I'm going to tell you right now, you have to know these 3 trig ratios. It's going to be the most important thing. It's going to carry through every single lesson in Unit 6. And once you get the hang of it, it's actually a really straightforward and I think fun process to go through. So I'm going to refer to this as SOHCAHTOA and obviously our trig ratios. So if you haven't copied your essential question down yet, do that first and then pause when you're ready and join us back in. But essentially here, just a little bit of overview and history for you. Mathematicians base the functions sine, cosine, and tangent, that's how you say them, on the ratios below, and it has to be in a right triangle. So that's really important for you to know. So we're only going to use these trig ratios if we see a right triangle. So here we go. Here are our 3 trig ratios. The first one is sine. All right, and sine you can use if you have the opposite side and you have the hypotenuse. So I'm going to refer to that as O over H. Excuse me. Cosine. We can use cosine if we have the adjacent side and the hypotenuse. So that would be A over H. And I'll tell you what the adjacent, hypotenuse, and all those mean in a second. And tangent, which we refer to as tan. You can use that if you have the opposite side and you have the adjacent side. So notice that we only have 3 letters here: opposite, hypotenuse, and adjacent. And each trig ratio is just a different combination of 2 of the 3 sides. Now, also a little side note here, where you see A in each of these, all right, that is just referring to an angle. So it might be using as a letter. You might see it as x. It might say find sine of x. It might say find sine of theta, which is a 0 with a diagonal line drawn through it. So again, it could be anything depending on what the problem is. So let's take a look at this example here so we can actually figure out, okay, what is the opposite, adjacent, and hypotenuse sides? All right, so if we take a look at this example here, it says in each case above, the letter A was representing angle A, and sometimes, like I already said, it might be denoted by the symbol theta, and other times we're going to always refer to it, though, as the vertex angle. So what we want to do here is you always want to circle your angle first. So we're talking about letter A, so I'm going to circle that angle. Now, you put yourself at this angle spot and you say, okay, if I was standing at A, which side would be the opposite side from my positioning? Well, if I stand here, remember opposite is always across. So this side over here, BC, would be our opposite side. So I would put an O there. The hypotenuse, if you think back, hypotenuse always has to be across from the right angle. So my right angle is down here at C. So the opposite side of the right angle is going to be AB. It's always also your longest side. I wanted that to be in purple. All right, let's try that again. So this would be my hypotenuse. And then the last side that's left is the adjacent side. And if you think about it, like I always refer to my classroom as adjacent to Mr. Endrice's room, or my classroom is adjacent to the mat room. Adjacent means right next to. So the last side that's left here is AC. So that's going to be my adjacent side because it's right next to angle A. So if we put your steps down over here to the right, so if you just take a second with me and we jot these down. So step 1, what you should always do first is circle your angle. All right, so in our case here, we were circling angle A because that's the one we were looking at. And then 2, you want to label the sides. So again, put yourself at that angle spot and say, okay, where's my opposite side? Go completely opposite from where you are. Then backtrack and say, okay, what's the hypotenuse? And then from there, you can always do whatever's left over is your adjacent side. So, trick for remembering which one of these. Like I said, refer to them as SOHCAHTOA. Now, there are some phrases. So, for instance, one of them is some old horse. Let me get a laser pointer here. So, we have some old horse caught another horse taking oats away. So, if you can remember that, it would also get the letter some old horse caught another horse taking oats away. We also tend to write them, Miss Griffin and I, like this. So a big S for so for the sine, and then a little O over H. So there's your ratio. Sine is opposite over hypotenuse. The C stands for cosine, and cosine is adjacent over hypotenuse, A over H. And then T stands for tangent, which is opposite over adjacent, if I can get that A across there. So this is something that you do need to know. So whether you just write it out SOHCAHTOA straight across, Miss Griffin and I, you're going to see us writing it like this with little fractions so we don't forget. That is something you do have to know, so make sure you put a star by that. So let's take a look at this example down here, example 1. It says consider the following two triangles, and it wants us to label the hypotenuse, so our H, the adjacent side A, and the opposite side based on the given angle. So in this first one, it says we're going to focus on angle C. So looking at my steps over here, it says the first thing we have to do is we have to circle that angle. So I'm going to circle C, and I'm going to pretend I'm standing right there. I'm standing where C is. So from C, I always start first by saying, okay, what's my opposite side? So if I was at C, I would go directly across from it. My opposite side would be where the 8 is. So I'm going to put an O there. My hypotenuse is always opposite of the right angle, so my right angle is down here, so opposite of that would be where the 10 is, so that's going to be my hypotenuse, and again, it's always the largest side, and that means the leftover side here, C to B, is my adjacent side, because it's right next to angle C. So that's your process for how you go about it. If you feel comfortable, pause the video, try this one here, but again, make sure you're focusing on angle A this time, and then press play, and then I'll have this filled in. If you're not sure, maybe give it a try, and then press play, and we'll go over it together. Okay, so if you tried it on your own, hopefully your picture looks like this. If you didn't, like I said, the first thing we're doing is we're given angle A, so I circled angle A. Opposite, so I'm standing at A, I'm going to walk across, and that's where my O is for my opposite side. Here's my right angle, so the hypotenuse is across from that, and then this leftover side here, that's my adjacent side because it's right next to the given angle. So we're going to take a look at some examples on the next page where we actually have to set up the ratios, and this was the first step in labeling them. So flip over to page 2 and I'll meet you there. So here we have example 2, and it says find the value of each trigonomic ratio in simplest terms. So, I mean, we're going to have to do a little bit of simplifying here. So the first thing you do when you look at all these pictures, like I said before, is you say, okay, I'm trying to find sine, and I'm trying to find sine of A. So the first thing I'm going to do is I'm going to circle A, because that's where I have to stand. Now, from A, again, my opposite side would be the 24, so I'm going to put an O by that. Hypotenuse is always across from my right angle, so here's my right angle. Opposite of that is going to be the 40, so that's my hypotenuse. And then, come on, there we go. And then the piece next to it, that's going to be my adjacent side. But now if we go back, again, it said I was trying to find the sine of A. So this is where I have to go back and I have to remember my trigonomic ratios, my 3 trig ratios. So I'm going to write them all out. So I have so for sine is opposite of hypotenuse. Cosine is adjacent over hypotenuse. TOA, tan, is opposite over adjacent. So a good habit to get yourself in is to write this out every single time you see a problem. And then what you do is you say, okay, based on this, the question says I want to find sine. So sine is going to be O over H. So that means I'm going to use the side that's labeled O, so the 24 here. And I'm going to need the side that's H, which is 40. So if we finish the problem by writing out our ratio, we would say sine of A, that's how you read it, is equal to, well, my opposite side was the 24 over the hypotenuse, which was 40. So that would be my answer, but it says in simplest terms, so I'm going to write it one more time. Sine of A. If you do a little simplifying here, 24 over 40, if you just type that in your calculator and hit enter, you will see that it simplifies down to 3 over 5. Both of them can be divided by 8. And that's your answer. Okay? All right, let's try this cosine one. So this time we're looking at the cosine, and we're going to focus on the cosine of x. So again, the first thing I'm going to do is I'm going to circle my angle. I'm going to go ahead and label my sides. So opposite of x is 10. So that's my O. Hypotenuse across from the right angle is my H. And then the leftover side here, this is going to be my A. So I have my 3 sides labeled. The next thing I want to do is I want to take a second and I want to write down my trig ratios. So I have sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and then tangent, t, which is opposite over adjacent. Well, this problem said I need to find the cosine of x. So I'm going to go over here, I'm going to circle the middle for cosine. So that means when I go to write my answer out, cosine of x, because again that's the letter I was referring to, I need my adjacent side, so I need 24 over h, which was 26. And then again, simplifying that, we would determine here that we're going to be left with, divide those both by 2, you'll get 12 over 13. And that's our answer. Alright, so I'll get you set up for this one, and then I'll see if you can finish it, and same with number 4 there. So this time it says tan of z. So again, we know our first step is always to circle that letter. So here's z. So I'm going to stand where z is. I'm going to label my 3 sides. So opposite of z is going to be over here, where the 30 is. My hypotenuse is always across from the right angles. That's my h, and then the a is the leftover piece there. Well, now I'm trying to find tan, so I need to take a second and write out my 3 trig ratios. So sine opposite over hypotenuse, cosine adjacent over hypotenuse, tan is opposite over adjacent, cross my a's. So again, I'm looking for tangent, so that means I'm going to need to use the 3rd ratio here. So if we write out our answer, tan of z, I need O over A. Well, here was my O, so 30 over A, and here was my A side, which is 40. And if you look at that, hopefully that's the one that in your brain you're like, oh, that can definitely simplify. 30 over 40, divide those both by 10. Tan of z is going to be 3 over 4. All right? So pause the video right now for me. Try number 4 on your own. You're trying to find sine of A, and then press play when you're ready, and we'll copy that one down and make sure our answers match. So pause. Try it on your own. I want you to, so do it right now. Okay, so I hope you tried that on your own. So looking at this one here, we had sine of A. So again, the first thing I did was I circled letter A. I said, all right, from A's perspective, 30 would be my opposite side. Across from the right angle is my hypotenuse, so 34, and then the leftover piece here, that's my adjacent side. I wrote out my 3 trig ratios. I went back and I said, okay, I'm focusing on sine, so I need O over H. So sine of A equals, well, my O was 30, the H was 34, so I'm up to this point right here. And again, it said in simplest terms, so make sure you simplify your answer. So if we type it in our calculator, 30 over 34, we're going to notice that they both can be divided by 2. So our final answer here would be 15 over 17, and we're done. So this is the first step in setting up trig ratios. You have to focus on your letter, first of all, label, and then from there, you pick the right ratio and substitute in. So this last example, we're going to look at example 3. This was a multiple choice question on last year's exam. So just move down to the bottom part for me. I have to flip to a new page because my iPad's being a little bit annoying here today. So just give me 2 seconds and then I'll meet you there. Okay, so example 3. And like I said, this was a Common Core exam question, so this is a level of difficulty that you're expected to be prepared for in June when you sit for the exam. It says, in the diagram below, triangle ERM is, here's our favorite symbol there, that stands for similar, remember, coming out of Unit 5, to triangle JTM, which statement is always true? So out of these 4 choices here, only one of them is going to be true. So the first thing I'm going to do, like we have been doing for 2 units now, is I'm going to stack my letters here. So I'm going to have ERM, and then I'm going to put JTM, just so it's clear to me which letter goes with which letter in the corresponding triangle. So Miss Griffin and I always recommend doing that first. Now, if you look at the next thing, notice that these two triangles here, they're not oriented the same way, meaning that this would be a good time when we want to flip and redraw them. So if I keep the big triangle how it is, so this is M, this is R, this is E, here's my right angle down here. I have side RE, and if I look here, R to E, that has to match with T to J. So this triangle has to get flipped so it matches my big triangle. So my smaller triangle, I'm going to redraw. So M is still in the corner, but we said R has to match with T, so I'm going to put T up here at the top, and then I have J down here in the bottom, and then here's my angle. So now what this allows me to do is I'm going to take a second, I'm going to use some different colors here, and I'm going to outline the sides that match up. So meaning R to E is the same as T to J. Then I have RM is the same as TM. And lastly, trying to get like a pinkish color here. Lastly, we have ME is the same as MJ. And I don't want to say the same, I should say corresponding. All right, so now if we go back and look at the actual problem here and what we're trying to do, it says that which of the following is true? So the first thing it says is cosine. So off to the side, I'm going to make sure I have my cosine and all my trig ratios actually for that instance written out. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So all I've done at this point, guys, honestly, is I've taken this problem, I've broken it down, I should say, into a problem that's going to be much more easy for me to understand and follow with all of these things here. With my trig ratios, with my letters stacked, and with my pictures redrawn. So I haven't even looked at the choices yet, but I'm already in a much better position to get this question right just by what I have here. So if we go back now and look at our choices like we said, it says the cosine of J. So cosine means I'm going to look at adjacent over hypotenuse, and it's referring to J. So if I come over here and I stand at J, it says my adjacent side should be RM and my hypotenuse should be RE. Well, if I look, RM is not even in my triangle here that has J in it. But since the triangles are similar, I can imagine that this is saying, well, instead of J, J would match with E. My pen will let me write E. So now what we need to do is I'm really standing over here at E, and I'm going to take a second and say, okay, from E's perspective, where's my opposite, my adjacent, and my hypotenuse side? Well, opposite of E would be over here where my green side is. My hypotenuse is always across from the right angle. And then my adjacent side is the one that's left over. So if I look over here, RM, we colored RM as being green. But if I look, RM is really O. So right away I can tell that choice 1 is not going to be the answer because from E's perspective, RM is the opposite side, and it says cosine where RM would have to be the adjacent side. So choice 1 is no good, just based on looking at that first ratio. So we move on here to choice 2. Choice 2 is still referring to cosine, so we're still going to use our A over H. But this time it says, okay, cosine of R. So I'm going to take a second, again, A over H. So R, I'm now going to move my perspective to be over here. I'll put a little box and change my colors so I don't have to erase all that. So it says JM. Well, if I look, again, JM's not even in the triangle with R. So what if we swap out R and replace it with its corresponding letter T? So now I'm over here at T. And again, I have to take a second. So, okay, from T's perspective, my opposite side would be down here at MJ. Hypotenuse is going to be over here at TJ, and then my adjacent side is what's left over at TM. So going back here, cosine of T, so again I'm standing here at T, for this ratio to be true, which is adjacent over hypotenuse, the question says JM is the adjacent side. Well, if I look, JM is not the adjacent side to T. JM would be the opposite side to T. So again, right away, this is not going to be the correct choice for the fact that they have opposite over hypotenuse, which is not cosine. That would be sine. Moving on. Tan of T. So now I gotta switch it up here and I'm gonna say, okay, I'm focused on tangent, so I'm gonna go back to, I'm gonna look at a new ratio this time. So I'm gonna put equals O over A. And they're saying tan of T. So thankfully, we already labeled this from T's perspective, so everything's labeled. But again, they're switching it up on us and saying, okay, well, look at RM. So again, RM is not even in my small triangle, so I'm going to swap out T and pretend I'm talking about R so I can put myself in the right triangle. So I'm over here at R. I have to put new letters on. So opposite of R is actually going to be down here now. Hypotenuse is still always going to be your hypotenuse no matter what. And this is now my adjacent side. So we're going to now focus on the purple letters. So tangent is opposite over adjacent. So if I'm standing at R, I need my opposite side from R to be ME, because that's opposite of where R is. But if I look over here, they're saying my opposite side is RM, which we know is not true, because RM in this scenario, I wanted that to be a highlighter, is really my adjacent side. So choice 3 is also no good. Meaning, we are left with choice 4 here, and choice 4 better give us a true statement. So we're saying, okay, tan of E. So we're still focused down here on our opposite over adjacent ratio. E, we already have E labeled with, we circled that in blue from before, but it's saying TM. And again, if I look, geez, TM's in my smaller triangle. I'm going to swap out E, pretend I'm standing at J. So now I'm down here at J, so I have to label, because I haven't labeled from J's perspective yet. Opposite of J would be over here. Hypotenuse, again, is always going to be your hypotenuse, and this side down here is now my adjacent side. So looking at this, I need opposite of J to be TM. And in fact, if I look opposite of J, what do you know? I do get TM. That matches. Woohoo! 1 for 1. Now, tan is opposite over adjacent, so I need my adjacent side to be JM, and again, woohoo! JM is my adjacent side, which means after this is all said and done, choice 4 is your final answer. So if you look, that question just took us 8 minutes alone to do just the one multiple choice question. That is not uncommon on your exam, so please don't give up just by looking at the question saying that's too much. Take a second, step back, redraw your triangles, write out your trig ratios like we did, get some different colors going so you can actually work your way to the correct answer. So that's it for skill 1. I know it's a lot of information, but really what you gotta know is your SOHCAHTOA, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent, how to set up trig ratios, and how to, we're gonna look at solving them next time. So I'll see you there. Bye.